first question is asking us to solve an inequality. We treat this in a very similar way to an equation. So we want to get our n's on one side and our numbers on the other. So here we can take away 11n from both sides. And we end up with 3n is bigger than 6. And here we go, dividing both sides by 3. We get n is bigger than 2. So n is bigger than 2 is our first answer. Now for our next one, we've got to draw an inequality on a number line. But you can see in the middle here, we don't just have x in the middle, we have this plus 3 in the middle. So to make sure we just get x on the middle, we need to take away 3. And we're going to take away 3 from both sides of the inequality here. So taking away 3 from minus 2 gives us minus 5. And taking away 3 from 4 gives us 1. So when we're drawing these numbers on an inequality, I'm going to put a little circle above minus 5 and above 1. So a circle here. And a circle here, and join them up. And then one of these circles needs colouring in. I always like to think of it as the one with more ink needs colouring into the one that is also equal to this one here has more ink on it. So we colour that one in and leave the other one open. And there we go, there's our inequality drawn on the number line. Okay, question 2. So this question wants us to draw a straight line, y equals 2x minus 3. Different ways of doing this. I quite like just to draw a table and to get some x values. So we have to draw this from x from minus 2 to 4. So I'm going to put the x values in from minus 2 up to 4. Minus 2, 1, 0, 1, 2, 3, 4. There we go. Now to find the y coordinate, it says up here y equals 2x minus 3. So we need to times x by 2 and then take away 3, or double x and take away 3. I'm going to start with the positive numbers, so I'm going to start over here on the right hand side. Double 4 is 8, take away 3 is 5. Double 3 is 6, take away 3 is 3. Double 2 is 4, take away 3 is 1. And at this point you might be able to see a little bit of a pattern emerging. These numbers are going up in 2, or if we go from right to left they're going down in 2. So I can just start to fill in the pattern. So take away 2 from 1 is minus 1. Take away 2 is minus 3, take away 2 is minus 5, take away 2 again is minus 7. There we go, so these are the values that we have to draw in. Obviously these are just coordinates, so this coordinate here, the x value is minus 2 and the y value is minus 7. So as a coordinate, that's how we plot that. So bringing that down on the graph, I'll start with 4, 5, then 3, 3, 2, 1, 0 minus 3, oh sorry, 1 minus 1, 0 minus 3, and the final two there, minus 1 minus 5 and minus 2 minus 7. So minus 1 minus 5 and minus 2 minus 7. There we go, and then nice and neatly with a ruler and a pencil, joining that up with a nice straight line. There we go, moving on to the next question. So we've got a trip being planned for 195 students, and they're going to take a sample of 30 students, and this shows the table about these results. So work out how many of the 195 students we think are going to want to go to the theme park. Obviously we can only give a best estimate here because it is only a sample, so we are going to assume that this is representative of all those 195 students, even though there's only 30. Now the amount that go to the theme park are 10 in this sample, and it's already said in the question it's 30 people in total. So in total in the sample, 10 out of 30 people want to go to the theme park. And if we simplify that down, that's 1/3. So we're going to assume using this sample that 1/3 of all students want to go to the theme park. So really all we're actually being asked to do here is to work out 1/3 of 195. Okay, so we just need to do 195 divided by 3, not forgetting this is a calculator paper, so we can actually just type that into the calculator. So if we do 195 divided by 3, we get the answer 65. Oh, should be an equal sign, there we go. There we go, so we will assume that 65 people want to go to the theme park based on this sample. Now part B touches on something I've already mentioned. It says state any assumption that you've made and explain how this might affect your answer. Well, we assume that the sample represents the rest of the school or the rest of the students. What was this question about? It was about students. It doesn't say whether they're at school. We'll assume that they're at school. So we assume that the sample represents all 195 students. Okay, so that's our assumption. It does say, explain how this may affect your answer. Okay, well there may be more or less. There we go. On to the next question. Okay, so a container is in the shape of a cuboid, 2/3 of it is full of water, and a cup holds 275 millilitres. What's the greatest number of cups that can be completely filled with water from the container? Okay, so first things first, we need to actually work out the volume of this container. So we can work out then what 2/3 is and how much water is actually in there. So to work out the volume of the cuboid, it's nice with a cuboid, you can just times all these three numbers together on the outside, the 30, the 6 and the 19, but as with any shape like this where we've got a constant cross section, we want to work out the area of this cross section and then multiply it by 6. So I'll do it in that correct order. We'll do 30 times by 19, the height of that rectangle, and then we'll times it by 6. And that gives us a volume of 3,420 centimetres cubed. So that is the volume of this rectangle, this cuboid at the moment, using that rectangular cross section. We now need to work out 2/3 of that. So divide it by 3, times it by 2. So 2/3 of 3,420, not forgetting you got a calculator still, is 2,280 centimetre cubed. So that's how much water that we have. It then says a cup holds 275 millilitres. So, at the moment our volume is in centimetre cubed, but we can turn that into millilitres, we can turn it into litres if we want. So to turn that into litres we need to divide it by 1,000, but then we're going to turn it back into millilitres anyway. So actually this question we don't actually need to convert between that because 2,280 centimetre cubed is 2,280 millilitres. Okay, but if we did have to turn that back into litres, we'd divide it by 1,000, that would turn it into litres for us, but then we're turning it back into millilitres anyway. So we've got 2,280 millilitres, each cup holds 275, so if we divide this by 275, it'll tell us how many cups we can fill. Now that comes out on the calculator as 8.29, but we're not really concerned about the fact that there's decimals here because the question says, what's the greatest number of cups that can be completely filled? Now we can't fill up part of a cup, that's not what we could do, but it's not going to be completely filled, so in total the only amount of cups that we can fully fill are the 8 cups there. Plus we'll have a little bit left over in that final cup, but we'll fill up 8 cups in total. Okay, on to question 5. So we've got a right angled triangle. We've got an angle in there and it's asking us to work out the length of AB. So we're working out the length of this one here and give your answer correct to 2 decimal places. So we're going to use Socrator for this. We're going to use some trigonometry. For the purpose of this example, I am going to use formula triangles. I know that there are different ways of doing this, but I'd like this to be accessible to as many people as possible. So I am going to use Socrator in my formula triangles. So best thing to do on this question is to write those out to start with. You can put little triangles around them if you want. I'm just going to write them out like that. And we need to label the sides. So opposite the 38 is the one we're looking for. So this is my opposite side. And we've been given the hypotenuse. Okay, so this side down here is the adjacent side, but we don't need to use that, okay, because we're looking for the opposite side. We've been given the hypotenuse, so I don't need to worry about this adjacent side. So I'm looking for my formula triangle that has the O and the H in, and that is your sine formula triangle. So I'm going to use this one. I'm looking for the opposite. So if you are familiar with using formula triangles, we cover up the O, and we're going to do a multiply, S times H. Now don't forget to put the angle with the sine button, so when you type this in the calculator, you're going to type in sine 38 and then multiply it by the hypotenuse. Just don't forget to put a bracket around your 38 there, you don't want that 16 going in with the 38. Okay, obviously you can write this another way, you can write 16 sine 38 as well, they mean the same thing, whichever way that you've been taught how to do this. So 16 sine 38, and if we type that into the calculator, we get the answer 9.85 when we round it to 2 decimal places. Good little tip is just to always make sure you write down the full number and then round it afterwards. There, you know, if you do make a mistake, then At least you've got the full answer written down there. You're not going to lose marks for rounding wrong in that final step. On to the next one. Sally uses her calculator to work out the value of a number y. The answer on her calculator display began 8.3. Complete the error interval for y. Well, if this is on our calculator, the smallest number that could possibly be there is 8.3. Okay, so, oh, that's not an 8. So the smallest it could possibly be is 8.3. Okay, there could have been lots of numbers after this 8.3 though. There could have been a 9 afterwards. There could have been lots of 9s and then some different numbers. But ultimately, the number that it couldn't have been is 8.4. Okay, if it had been 8.4 and then anything after it, it would have rounded to 8.4. Okay, so there's our error interval, 8.3 to 8.4. It can't be 8.4, it has to be less than 8.4, but it can be anything from 8.3 up to that number. So that is question 6. Right, question 7, we've got some ratios. So £360 are shared between these 4 people. It gives us a ratio of the amount that Abby gets to the amount that Ben gets. So that's important there. The amount that Abby gets to the amount Ben gets is 2 to 7. And it says Chloe and Dinesh each get 1.5 times the amount that Abby gets. So let's have a look. We've got Abby, Ben, Chloe and Dinesh. Now Abby and Ben get theirs in the ratio 2 to 7. Now if Chloe and Dinesh each get 1.5 times the amount that Abby gets, well, if Abby gets 2 parts, timesing that by 1.5 gives you 3, and 3 because they both get 1.5 times what Abby gets. So that's our ratio for the amount that all 4 of them get. It says work out the amount of money that Ben gets. Now all we need to do is split this into a ratio. So these parts all add up to 15. So there are 15 parts. And if we do 360, divide it by those 15 parts, it tells us that there is £24 per part. Now, we can easily times them all by 15 if we want, so we can say that Abby gets 2 lots of 15, which is 30, and keep multiplying them all. But the one that we are actually interested in here, sorry, not 2 lots of 15, 2 lots of 24, so Abby would get 48, and so on. But the one we're interested in is Ben, and Ben gets 7 parts. So 7 lots of this £24 that Ben's going to get is £168. And there we go, that's how much Ben gets. Moving on to question 8. Okay, so we've got a little bit of standard form. It says to write this number in standard form. So it is a small number here, 0.00562, so we are going to have a negative power with this. We just need to have a look at how many jumps, so I'm going to rewrite it because it's quite small, 0.00562. So to make it a number between 1 and 10, I want the decimal to go there, 5.62. So I want it to be 5.62 times 10 to the power of 1, 2, 3 jumps, so minus 3. And the next one, right, 1.452 as times 10 to the 3 is an ordinary number. I'm going to rewrite this again, so 1.452, 10 to the power 3, so it's getting bigger, 1, 2, 3, 1,452. Okay, and on to question 9. Okay, so it says the circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area of circle A to the area of circle B. So we're looking at scale factors here and what happens between length and area. So first things first, if I write the ratio of B to A based on their lengths, we get 9 to 10. Okay, if I just imagine that circle A has a circumference of 10. 10 or 100 is always quite a nice one. I've picked 10 for this one because it's quite nice and easy to work out 90% of 10, and that is 9. So B is 9, A is 10, and that is my length scale factor. Now to get the area scale factor, you have to square both these numbers. So 9 squared is 81, and 10 squared is 100, and that is my area scale factor. I've got to be careful here, it does say find the ratio of the area of A to the area of B, so I just need to swap those over. It's 100 to 81. Okay, that's purely based on the way I decided to write it to start with. I could have written A to B to start with and had 10 to 9, not had to worry about that. But I've kept it in the order that the questions talked about it. On to the next part. We've got square E has a length of E and square F has a length of F. And it says the area of square E is 44% greater than the area of square F. So again, I'm going to think about numbers here that I could potentially move from area scale factor to length scale factor. Now I could use 10 again, and I could say that E to F is 44% greater. So if I pick the number 10, 44% of that would be 4.4. So I'm starting to get decimals introduced. So rather than picking 10 this time, I'm going to go for the number 100. So if F's 100, then 44% more than that is 44 more, so E would be 144, and this works out quite nicely because, as you've hopefully noticed, they're square numbers, and this is an area scale factor, and it wants us to move back to length. So to get this back to length, I'm going to have to square root both these numbers. Square root of 144 is 12, and the square root of 100 is 10. So there is my ratio 12 to 10, and I have kept it in the order that it wants this time, E to F. So my answer would be 12 to 10. There we go, moving on to the next question. Okay, so we've got some probability, and we're going to have to fill in this probability tree. So it says this is about Mary travelling to work. Probability that she's late is 0.15, and the probability she's not late we're going to need to work out because it gives us the 0.15 here already on the tree. Now it doesn't say there's any difference between Thursday and Friday, so before we even work anything out, we can put 0.15 into all the late spaces. It doesn't say in the question, you know, if she's late on a Thursday, it will change how late or not late she is on any other particular day. So 0.15. Now these two branches of the trees have to add up to 100 or add up to 1 when we're looking at a decimal. But again, I always like to think of these as percentages. That's 15% there, 0.15. And then the probability she's not late will be 85%, which is 0.85. So we can fill those again in all these trees, 0.85, 0.85. There we go, we've completed the tree. Now it says as part B, work out the probability that her train will be late on at least one of these 2 days. Now at least one of these 2 days means she can be late on both days as well, can't they? So she could be late, she could be late and then not late, and she could be not late and then late. So in all these three probabilities here, there's at least one of the days she's going to be late. Okay, but this one down here is no good to us because she's not late on both those days in that situation there. So if we work out these three probabilities, we just have to multiply across the tree. So moving along this branch here, late and then late, I need to do 0.15 multiplied by another 0.15, the two probabilities on that part of the tree. Looking at the next part of the tree, we could have late and then not late, and that would be 0.15 multiplied by 0.85. And that final part of the journey, we could have not late and then late, and that's going to be 0.85 times 0.15. Okay, so there are three options. When we've got multiple probabilities that are going to combine to make this overall probability, we're going to add all these together at the end. So I'm just going to bring that down here and work them all out. So our first one was 0.15 times 0.15, and that equals, okay, there we go, 0.0225. We also had 0.15 times 0.85, and that is 0.1275. And the final part of the tree there, which was the same just in reverse, 0.85 times 0.15 is going to equal the same, so 0.1275. Okay, so we just need to add those all up. Add 0.0225, and that equals in total 0.2775. Okay, it doesn't say to round it or anything, so we're not going to round that, we're just going to leave it exactly as it is, 0.2775. Just as a little note, you could have done this a slightly different way. I've opted not to, but you could have worked out this probability here, the probability of not being late and not being late, and that's 0.85 times 0.85, which gives us a probability down here of 0.7225, and then we can take that away from 1. It's a lot quicker. 1 take away 0.7225 again gives us 0.2775. So 2 ways that you can approach that. I've opted not to. I've opted just to go with the 3 branches there and working out those. But that's your answer, 0.2775. On to your next one. Right, we've got to work out, we've got to draw a cumulative frequency graph. So at the moment, this has given us the frequencies up here, and it's given us another table down here to write in our cumulative frequencies. So at this point where I've drawn the first arrow up here, we have a total frequency of 5. Then we have a frequency of 30, so adding that in, we have 35 in total. Then we've got another 20, so 55. Adding in another 15 gives us 70. Adding in another 8 there gives us 78, and finishing off with that final 2 gives us 80. Now sometimes in the question it says what this total is going to be. We'll just have a quick look. It does actually say that, so we know we're right. It does say, look, 80 office workers. So that's a nice little hint to us that we've done it correctly. Now we just have to actually draw these points. So what do we have? 5, 35, 55, 70, 78 and 80. And these are going to be plotted on a cumulative frequency graph against these end points here. So we're going up in 20s there. So we're starting at 20, 40, 60, 80, 100 and 120. So that first one, 20 and 5. I'm going to bring it over to here. So 20 and up to 5 as accurately as you can. Then we had 40 on 35. We had 55 for the next one. We had 70 for the next one. Then it was 78 and 80 for the last one. There we go. Now we just need to join this up. I'm just going to have a quick look again where this actually started. So if you have a look just here at the start of the graph, it starts at 0. So I'm just going to make sure I connect that from 0 right up to the end point and draw a nice smooth curve. I'll do this as best as I can. There we go. Nice smooth cumulative frequency graph. Now part C says use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. So first of all we need to find, well, actually how many take more than 90 minutes. Now 90 minutes is down here in between 80 and 100. So using my graph, if I go up and see where that lands and then across, do it as best as I can on here, that is 75 based on my graph. So above that, from 75 up to 80, those extra 5 people are going to take more than 90 minutes. So I've got 5 people. Okay, 5 people take longer than 90 minutes. So I need to work out, well, what's that as a percentage of these 80 people? So we can just type that in as a fraction onto our calculator, 5 out of 80, and then times that by 100. Okay, probably the easiest way there to actually work out this as a percentage. So I'll just work that out. You can do that on a calculator. So 5 divided by 80 is, let's scroll this down, 5 divided by 80 gives me 0.0625, times that by 100 gives you 6.25 for my particular graph. Again, you might get something slightly different here. There is a range of answers that you can get based on your curve here. So if you're getting something close to 6.25, then that's absolutely fine. On to question 12. We've got a circle sector. It says the radius is 7. That is given to us on the diagram as well, so I don't need to label that. But it says the area here is 40 centimetres squared. Okay, and then it says to calculate the perimeter of the sector and to give our answer to 3 significant figures. Okay. So, first things first, I need to have a look at actually working out the angle that is actually within this sector here, because it doesn't tell us what the angle is. So we can actually work that out. So, to work out the area of a circle, it's pi r squared. So write down area equals pi r squared. But it actually tells us what the area is. It says the area is 40. So I can say, okay, well, 40 is equal to pi times 7 squared, and then times whatever fraction of the circle this is. Now we don't know what fraction that is, so I'm just going to put x over 360, the amount of degrees in a circle. Okay, so I can take that from here, I can actually just then rearrange this equation, and that should then tell me what that angle is, and I'm going to keep that as accurate as possible. So if I first divide both sides by, and we can just straight up divide by pi, this part here, pi times 7 squared. So I can do 40 divided by pi times 7 squared, and that equals x over 360. And then I can just times both sides by 360. So I won't write all the little steps down on the calculator, but we'll times both sides by 360. And that gives us the answer 93 point, I'm going to round this to 2 decimal places because it's very, very close, 93.54 degrees, just keeping it a little bit more accurate here than the 3 significant figures that it's asking for, 93.54. So now we have the amount of degrees in this circle sector there. We've got 93.54. You can label that on if you want, 93.54. And we can now use that to work out the perimeter of this sector. So coming back up to the top, let's have a look. So we're going to work out the perimeter, which means we need to find the length of this arc, okay, which is part of the circumference. And the formula for circumference is pi times diameter. Okay, but to find the length of this arc, we're going to use a similar process like we did down here. We're going to multiply it by now 93.54 over 360. So to find the length of that arc, we'll do pi times the diameter, which is 7 add 7. So the diameter I'm going to write over here is 14. So pi times 14 multiplied by 93.54 out of 360, the fraction of the circle that we're actually looking at. And then we're going to add 14 to that. So typing all this in, pi times 14 times 93.54 over 360, add 14, the two lengths of the radius here. We've got the 7 here and the 7 here for the full perimeter round. And that gives us a total length there of 25.428. And then again, just remember, it did say 3 significant figures, so rounding that we get 25.4 centimetres. There we go, and there's our final answer, 25.4. Been a little bit all over the place, that question, so putting that down here, 25.4 as our final answer. On to the next one, we've got some algebraic fractions. We've got quite a lot going on this one. So we've got 6 add, and then we've got these 2 little algebraic fractions getting divided here. And we've got to show that it simplifies to ax minus b over cx minus d. There we go, and it does say that a, b, c and d are all whole numbers, all integers. So I'm going to turn all these pieces into fractions to start with. So 6 I'm going to write as 6 over 1. I'm going to add that to, in this bracket, x plus 5 over 1. And we're dividing that by x squared plus 3x minus 10 over x minus 1. Now, before I write this down, I've just noticed that this quadratic here, this x squared plus 3x minus 10, does factorise. So I'm going to factorise that. I can do that to the side. X squared plus 3x minus 10. So the factors of 10 are 1 and 10, or 2 and 5. So I can make 3 out of 2 and 5, so that's going to factorise with 2 and 5. So x and x, 2 and 5. Just need to get the symbols right. I want to make positive 3, so I'll have plus 5 minus 2, and that is over x minus 1. There we go. So looking at what's in the bracket here, so we need to do what's in the brackets first. You can see that we've got to do a divide, so I need to flip this second fraction over, do the reciprocal of this second fraction here, this one. I'm going to rewrite all of this. So 6 over 1 plus x plus 5 over 1 multiplied by x minus 1 over x minus 2 x plus 5. And there we go. Now we can start to tackle the left fraction and the bottom of the right fraction. So we can cancel those, we can cross cancel those and get rid of that. So dividing these by x plus 5, we get 1 on the top, and that 1 there will just leave us with x minus 2 on the bottom of that one. Now if we times these fractions in the bracket together now, this is quite nice because this left fraction here is just 1 over 1. Then what we actually have left is 6 over 1 plus, 1 times x minus 1 on the top there gives us x minus 1, and 1 times x minus 2 on the bottom there just leaves us with x minus 2. Okay, now we're almost finished, we've just got to add these together now. So as with all fractions, when we're adding fractions together, we need a common denominator. So I'm going to times this left fraction here by x minus 2 on the top and the bottom, and that's going to give us a common denominator of x minus 2, and then we can actually add them together. So times in the top by x minus 2 gives us 6x minus 12, and times in the bottom by x minus 2 gives us x minus 2. We're going to add that to x minus 1 over x minus 2. Okay, that's nice and easy for the bottom. When you're adding fractions, just keep that denominator, so we have x minus 2 on the bottom. We just need to be careful here on the top. So we've got 6x, and we're adding x to that. So 6x add this x, so this 6x, and we're going to add this x. So in total that gives us 7x. And then we've got negative 12 add negative 1. Now if you need to, or you want to, just to the side, let's just write that down. Negative 12 add negative 1. Okay, so when we're adding a negative, that's the same as just taking away. So negative 12 take away 2 is minus 14. I've just realised I've just written minus 2 there. It's not minus 2, it's minus 1. Well done for reading the question. Okay, so negative 12, take away, add negative 1, take away 1. There we go, that definitely says 1, not 2. So negative 12, take away 1 is minus 13. There we go, and there's our final answer. 7x minus 13 over x minus 2. Just quickly check the question, make sure it's in the format that they wanted. And it did say ax minus b, yep, so a is 7, b is 13, c is 1, and d is 2. So 7x minus 13 over x minus 2. And on to the next question. Okay, this isn't the easiest one to draw on here, but we have to draw a tangent for this question. It does say to calculate an estimate for the gradient at the time when t equals 15. So t equals 15 is here. So I want to draw a tangent just there on the graph. So with your ruler and your pencil, a nice line that just touches the curve at that point. I'll draw it as best as I can. There we go. A little tangent that just touches the curve at that point. We then need to work out the gradient of that tangent. So what I like to do is just to find, ideally, and it's okay because we have a calculator here, just some numbers that I can read quite nicely. So that looks like 11 here. I'm going to go from here down the bottom, and I'm going to go across. I'm going to try and make it as big as I can. I'm going to go along to 20. There we go, and up. There we go. So to work out the gradient, we do our change in y over change in x. Okay, or you might have known rise over run. And we're going to work out the gradient from here. So the run there, I've gone from 11, just make sure you read that nice and carefully down here, that is 11, up to 20, so that's a run of 9. And then the height changes, it goes from 15 here, up to this number here, which I am going to have to just read nice and carefully. That is, for me, 21.5 over here. Each 2 squares goes up 1, so that'd be 21.5. So from 15 up to 21.5 is 6.5. So the change in y I've got as 6.5. The change in x I have as 9. So just down here I'm going to write down my working out. The change in y I've got as 6.5. The change in x I've got as 9. So 6.5 divided by 9 gives me an answer of 0.72 recurring for my answer there. Okay, and again, this does depend on your tangent. Okay, so there's quite a range that you can get for these. I think when I did it on paper, I got 0.6, I got 7.5 and 12.5 as my 2 numbers there. But it will change just depending on how you draw that tangent. You just need to make sure you're doing it as accurately as possible with a ruler and a pencil. Now the next part of the question says describe what this represents. So just having a look at our graph, we've got speed against time. Okay, so a change in speed over time is an acceleration. So this represents acceleration. There we go, so acceleration. Oh, and there's another part. Work out an estimate for the distance the car travelled in the first 20 seconds of its journey and use 4 equal strips. So that is up to the first 20 seconds. So yeah, there's a lot of drawing on this graph. So, assuming that we've already got stuff drawn on here, I'm going to leave that there. So 4 equal strips up to 20. So that's where I'm going to stop. So equal strips will be in 5s. So that'll be there, there, and on 15 there. So we've got 4 shapes that we can actually do here, that we're going to work out the area underneath for the distance. So I've got a triangle in the first strip, I've got a trapezium in the second, a trapezium in the third, and a trapezium there in my fourth. Now this one is quite fiddly, so we're going to have to work out all these different heights just so that we get these right. So that's a height of 4. That there looks like I've drawn over it quite a lot, but that is a height of 12. This here is a height of, but I've got a lot of pen written all over that, but 16, 17, 18, that is a height. And the final height there is 20. So I need to work out the area of these 4 shapes and add them all together for that total distance. So I'll try and do this with minimal work. I'm going to do the working out over here on this part of the question. So for that first shape, the triangle, I have base times height divided by 2, so 5 times 4. I'm going to write them all down. Let's label that number 1. 5 times 4 divided by 2 gives me a distance of 10. Let's have a look over here. The speed is in meters per second, so that's 10 meters. Shape number 2 is a trapezium. So add together the parallel sides. 4 plus 12 is 16, divided by 2 is 8, and then times it by the height, the distance between them, which is 5. So 4 plus 12 is 16, divided by 2 is 8, and then times that by 5 gives us 40 meters for number 2. On to number 3. Same process again, it's a trapezium, so 12 plus 18. Let's scroll this down a little bit. 12 plus 18 is 30, divided by 2 is 15, and again times it by 5 is 75 meters. There you go, 15 times 5. And then the final one there, let's just have a quick look. We've got 18 and 20 as our 2 parallel sides there, so 18 plus 20 is 38, divided by 2 is 19, and again times that by 5, and that gives us 95 meters. Again, just make sure you are writing this in the right part. I'm just writing it here obviously because the question's just above that. And don't forget you do have a calculator, so just be very, very careful when you are doing these sums that you do get them right. Right, so we have 10, 40, 75 and 19, and we need to add those all together. So 10 plus 40 plus 75 plus 95 gives me a total distance of 220 meters. Again, I believe when I did this on paper I did get 210, so just be very, very careful. One of my numbers might just be slightly off up there, so just be super careful when you are doing that you read them nice and carefully. But for the purpose of this one, I've got 220 from what I can see. There we go, so 220 meters. Right, on to the next one. Make m the subject of the formula. Right, so we've got an m on the bottom and on the top. We've got the m here and the m here. And whenever we see this, there is going to be a point where we're going to have to factorise. So we need to get the m's next to each other, and then we were able to factorise that into a single m for the purpose of our formula. So let's get rid of this denominator to start with. So we'll times both sides by m minus 1. There we go. So we have f brackets m minus 1 equals 3m plus 4. Let's expand this bracket out. So f times m is fm, and f times negative 1 is negative 1f. So I'll just write minus f. And that equals 3m plus 4. Now we need to get these m's next to each other. So I'm going to decide to add f to the other side, and I'll bring that 3m over. So we have fm equals 3m plus 4 plus that f that we've just moved over. Now we can take this 3m over to the other side. Let's move that down. And that leaves us with fm minus 3m equals 4 plus f. Factorising this left part here, we get m brackets f minus 3 that equals 4 plus f. And then we can finish this question off. We can divide both sides by this bracket, this f minus 3, and that will leave us with m equals 4 plus f divided by f minus 3. And there we've made m the subject. Just as a little note, you could have done this in a slightly different way. I've decided not to show you both, but at this point here, I could have instead decided to subtract fm from both sides and then subtract the 4. I've decided not to, because if I do that, it ends up leaving this negative sign in front of the f. So rather than forgetting to do that, or rather than having lots of negative symbols everywhere, I've decided to keep it in a tidier way. But there is two answers to this, two ways that you could do it. I've decided to just do it this one way though, but there's our answer. Right, question 16, got some coordinate geometry. It says the straight line L has the equation 3y equals 4x plus 7. Now straight away when I look at that, it's not in that y equals mx plus c format because we've got this 3 in front of the y. So I want to have it as a single y at the front. So first things first, I know I'm going to have to divide everything by 3 there. It then says the point A has this coordinate, 3 minus 5, and it wants me to find the equation of a straight line that's perpendicular to L and passes through that point A. So first things first, let's get this equation, 3y equals 4x plus 7, and let's actually divide that by 3. So we get y equals, now 4 divided by 3 is a fraction, or is a decimal on the calculator if you want to do that. I'm going to leave it as a fraction though. I'm just going to write 4 over 3, 4 divided by 3 is 4/3. And the same with the 7, I'm just going to leave it as 7 over 3 rather than having some long decimals to have to write down. There we go, that's the equation of this line L. Now in order to get a perpendicular line, I need to actually do the negative reciprocal for this gradient here. So the first things first, I'm going to write down at the moment the gradient, which I refer to as m, because m is the piece in our equation of a line up there. So m is 4/3. Negative reciprocal just means I flip it over, I do the reciprocal, and I change the symbol in front of it. So this is a positive 4/3. So the perpendicular gradient, which I refer to as mp, is negative 3/4. Okay, so that's my negative gradient. So far we've got a lot of information here that we need for this question. We know that the equation of this new line we're going to write is going to be y equals. We know that the gradient of that line is going to be negative 3/4. But we don't know the c, the part where it intercepts the y-axis. So that's where this coordinate comes in. I can now sub that into this equation to find out what c is. So x is 3 and y equals minus 5. So x is 3, y equals minus 5. So minus 5 is y, x is 3, so it's negative 3/4 multiplied by 3, and then plus c. Now both these sides have to balance. As soon as we find out what balances them, that will give us our c, and we can write our equation. So we just have to actually work this out. So let's do this bit first, this negative 3/4 times 3. Okay, so minus 5 equals, times this by 3, and we can write this as a fraction 3 over 1 if it helps you to see it. So minus 3 on the top times 3 is 9, so we're going to have negative 9 over 4 times 1 on the bottom, minus 9/4 plus c. There we go. To get c on its own, we have to add 9/4 over to 5. Now you've got a calculator, so you can probably do this quite easily on your calculator, but I'm just going to think of this as a mixed number instead. Nice good non-calculator skill. So 4 goes into 9 twice, with a remainder of 1. So it's negative 2 1/4. And if we add that over to the minus 5, so plus 2 1/4 and plus 2 1/4, that leaves us with, and up to you whether you want to add this on that way, let's have a think. So add 1 is minus 4, add another one's minus 3, add the quarter is minus 2 3/4. That equals c. There you go, you've got a calculator though, so you can probably do that in a slightly easier way. Okay, so it's up to you at this point. You could write this as minus 2 3/4. We could turn it back into an improper fraction if you'd like. So 2 times the 4 is 8, plus the 3, we could write it as minus 11/4. That equals c. But it's actually okay to leave it in either way. We could even write it as a decimal if we wanted. But putting that all together, putting the c back in place up here in your formula, okay, we get y equals minus 3/4 x minus 11 quarters, or 2 3/4, or 2.75. I tend to not to like to mix fractions with decimals here, so I'd change this to 0.75 and I'd change this to 2.75 if I was going to decide to do that. Okay, so just writing that in, y equals minus 3/4 x, take away 11 quarters. Okay, right, on to the next question. Okay, question 17. So it says that there are some small and some large cubes in a bag, and the cubes are red or the cubes are yellow, and then it tells us a ratio about some of these bits of information. So it says small to large is 4:7, and red to yellow is 3:5. Okay, it says explain why the least possible number of cubes in the bag is 88. Okay, so if we have a look at these ratios, the total of this ratio here is 7 plus 4, 11, and the total of this ratio here is 3 plus 5 is 8. So this first ratio has to be in multiples of 11, this second one has to be in multiples of 8, and the lowest common multiple of these two numbers is 88. Okay, so all I have to say is the lowest common multiple of 11 and 8 is 88. There you go, and that's part 1 done. The next one says all the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. Now the wording on these questions really does tend to throw people, but let's just start to break it down and have a look at what we've got. Now up here in this first ratio, okay, it tells us here that the small cubes to the large cubes is 4:7, and it was out of 11, wasn't it? So those small cubes there, as a fraction, is 4 out of 11. So to find out how many small yellow cubes there are, we'll times that by the fraction that are yellow, which I'll get from this ratio, which is out of 8. Now the yellow there is the 5, it says red to yellow, so 5 is the yellow. So that's 5 out of 8, okay, and that gives us 20 on the top and 88 on the bottom. And there we go. Right, what else can we work out from this? So we know that there are 4 11ths that are small in total, so I could also have a think about now of how many are actually small. So we've got 4 11ths of 88. So there are 88 counters potentially if we look at the smallest amount. Divide that by 11 is 8, times it by 4 is 32. There we go. That are small. So we've got small and yellow, 20, and we have 32 in total so far that are small. Now we could also have a look at the large as well. So let's have a flick and have a look at the large. So coming back up, large cubes was 7 there in that ratio, 4:7. So large will be 7 out of 11. And again, timesing that by the amount that are yellow, which is 5/8, gives us 35 out of the 88 that are large and yellow, 35/88. Okay, so in total, we have 20 that are small and yellow, 35 here that are large and yellow. So 20 plus the 35 gives us 55 in total. Okay, now if there are 55 in total that are yellow, that is split between the small and the large, and we've already worked out just here that 32 of them are small. So to figure out how many of those are large, we can do our 55, take away the 32 small ones, and we get 23 that are large. There you go, so 23 large. On to the next question. Okay, so we've got some circle theorems. A, B, C, D lie on a circle. C, D, E is a straight line, so C to D to E. And then it says B to A equals B to D, that's given to us. C to B equals C to D, that's also given to us. And angle ABD equals 40, which is there in the diagram. So nothing actually to label on there. It says work out the size of angle ADE. So ADE is this angle here, which is part of this straight line CDE. and it says you must give a reason for each stage you're working. Now the first thing that stands out to me is this triangle ABD. Okay, and the fact that A to B is the same as B to D, this is an isosceles. So first things first, I'm going to work out these base angles. So base angles in an isosceles are equal. So if we do 180, take away 40, that leaves us with 140 degrees. Divide that by 2, gives us 70 degrees in each angle there. I'm going to label those in 70 and 70. So I haven't actually had to use any circle theorems yet. Now my reason for that would be base angles in an isosceles are equal. Okay, I tend to like to label my working out so I know what I've done first. So moving on to the second part, which I'm going to put over here. A little bit disorganised because I'm keeping it up the top of the screen. But now I'm looking at this quadrilateral. Now it says A, B, C and D lie on the edges of the circle, or lie on the circle on the circumference, which means A, B, C, D, and if I remove some of this, we actually have a quadrilateral within the circle, which is called a cyclic quadrilateral. Okay, and opposite angles in a cyclic quadrilateral add up to 180. So opposite that 70 is this angle C just here, and that would have to be 110. So that is angle BCD. So BCD equals 110. There we go. My reason for that would be opposite angles in a cyclic quadrilateral equal 180, which I'd have to write down. Remember it said give all your reasons. Opposite angles in a cyclic quadrilateral equal 180 degrees. And that was my second step. Now again, let's get rid of that. We've got another isosceles triangle here, BCD. And we know the top angle in that is 110, so I can work out the two base angles again. So step 3, it's the same as step 1, it's at the top angle is 110. So 180, take away 110, leaves me with 70, which I'm going to split between the two angles, 35. So this angle here is 35, and this angle here is 35. Okay, let's get rid of that. Okay, so now we've got this line here, CDE. We've got the two angles on it. We've got 35 for one of them, 70 for the other. And we can now find what's missing because we know that angles on a straight line add up to 180. So my final step here to finish it off would be 35 plus 70, which equals 105, and take that away from 180. And that leaves me with 75 degrees. I should probably add in one more explanation here, that angles on a straight line equal 180. There you go, angles on a straight line equal 180 degrees. Just make sure your answer is nice and clear. 75 degrees is my final answer there. Okay. Always a good thing to do here, just to make sure that you label everything that you can see all over the diagram. Even if you're not too sure on how to finish these types of questions, you know, that first thing that I did there, finding the base angles in the isosceles, a really good way to just get started and start labeling the diagram. Okay. So we've got a triangular prism, and it's asking us to work out the size of the angle between EM and the base of the prism. A lot of time these questions sometimes say the plane, and they might say the plane ABCD, which is also the base of the prism, but it says the base of the prism. So between EM and the base of the prism. Right, now where's EM? So it says here, M is the point on DA such that D to M, M to A is 2 to 3. So D to A is just there. Now it's closer to D than it is to A because it's 2 to 3. So it's something like here, and that is point M. So it wants to know the angle between EM, which if I try and draw it in, is from E to M, and the actual base of the plane, which if I draw along the base, brings me over to B. So I've got another right angle triangle going on there, as well as the right angle triangle on the side. So let's have a look at what we can do. Now at the moment, I don't know M to B, I don't know M to E, I don't know any of the angles other than the fact that this is a right angle. But looking at this, and if I just try and get rid of part of this, if we look at this side here, I can work that out, okay, because I've got this right angled triangle sitting on the side here. Okay, so if we look at that to start with, I'm going to draw it off to the side. We have 35, a base of 15, and we're trying to work out this side here. So again, we're going to use a little bit of SOHCAHTOA here, which we did on the previous paper, or I think earlier on in this paper actually. So this is our opposite side, and this is our adjacent side. So this time we're not going to be using the hypotenuse. Okay, so we don't need that. And with O and A, remember to write out SOHCAHTOA, but that is our tan formula that we're going to use. So to work out the opposite, we're going to multiply, cover up the O. So we're going to do tan 35 multiplied by the adjacent, which is 15. Okay, I'll write in that 15 tan 35. Now that gives us an answer. I'm going to keep this as accurate as possible. 10.503113. A few more decimals, but it does only want your answer to one decimal place, so I think going to 6 there is plenty enough. And that is the length of EB. So I'm going to write that up here. 10.503113. Okay. Coming back to this line that I've erased from M to B. Now, is there anything we can work out from here? I can't use that 10.5 to actually get any more length in that triangle because, again, I don't know any of the angles. So there must be another way of getting this M to B. Now, if you have a look on the base there, I'm going to try and redraw it. I'm going to draw this just the base as if I was viewing it from above. M is sitting here and B is sitting there. And we know that this is 15. We know this is a right angle because it's a rectangular base, but we're trying to work out this. Now it tells us that this full length here is 15. Actually, just notice, obviously, I've just said it's a rectangular base, it's actually a square base, isn't it? 'Cause it's 15 and 15. Okay, so it does tell us the ratio was 2 to 3. So I could actually work out what this length is here, okay, or on the diagram, this length is here. Because I can split that in the ratio 2 to 3. So 15 divided by 5 is 3, and I can share that in the ratio 2 to 3, so it would be 2 lots of 3, which is 6 there, and this would be 9. So that length is 9. And actually now I've got a little right angled triangle here. There we go, and I can work out what this length is, which is the, on my diagram, the base there. Right, so we can use Pythagoras. We're trying to find the longest side, the hypotenuse. So to work that out, which I'm going to call M to D, I would do 15 squared plus 9 squared, and then square root my answer. Okay, so once we square root that, all on the calculator, we get 17.493. Okay, there we go. I'm going to underline some of these numbers here so that I don't lose them. And now I should be able to hopefully finish this off, because if we get rid of that piece there that we were looking for, I can now label that as 17.493. Starting to get very messy now. Try and keep this as tidy as possible. Right, so finishing this off, I've got this triangle here, M here to E, here to B. So I'm just going to redraw that completely separate because my diagram's starting to get a bit messy. So I'm going to draw it as best as I can. M, just have a quick look. E was at the top, B at the bottom. E, B. We worked out that this one was 10.503. I'm going to leave it as that, and the bottom is 17.493. Okay, which we've just worked out. Yep. And the question wanted me to work out the size of the angle between EM and the base of the prism. So that is this angle here, okay, which on my little diagram down here is this angle here. Okay, so to find an angle in a right angled triangle, again, we're going to use SOHCAHTOA, we're going to use some trigonometry, and we're going to look at using the opposite and the adjacent again. And again, we don't need the hypotenuse, so we don't need to worry about that. So again, we're going to be using tan again, TO8. And we want to find out the angle, so we'll cover up the tan part, and we go and do the opposite divided by the adjacent. Now remember, when you're trying to find an angle using trigonometry, press Shift tan, which will bring up tan minus 1 for finding angles, and then we just input the opposite over the adjacent. So the opposite is 10.503, the adjacent is 17.493, and typing that into the calculator, we get the value 30.98 degrees. I could write down a few more digits there, but it wants it to one decimal place. So from this point I can round it, and that would give me 31 it would round up to. And then because it wants one decimal place, I'm going to keep that as 31.0. There we go, so 31.0 degrees. And that's the end of that question. On to the next one. Okay, I think this must be the last question. Yes, it is the last question. So we've got a vector here to do. This is quite nice because they've split it up into part A and B, which tends to have not been shown very much at the moment. But we've got it split up into A and B. So for part A, which we'll start with, it says express f to E in terms of A and B. So I need to get from f here to E here. And it's given me some vectors that I can label on there. So it says C to D is A. C to D is there, and that's an A. So an A movement moves me that way. D to E, so all the way down here, not just to the M, but all the way down is B. And F to C, this one here in the right direction there, F to C is A minus B. Okay, so to get from F to E, that's not actually too bad. We go up through this A minus B, so A minus B. Then we add in an A going this way, so add A. And then we go down this way, adding in a B. And if we collect these together, we've got A, add A, which is 2A. And swap to a different colour, we've got minus B, add B. They cancel each other out, so our final answer there is 2A. Okay, on to part B. So part B says M is the midpoint of DE. Okay, I'm going to just get rid of some of this stuff that I've been drawing on, these little arrows, because we don't need that anymore. We'll go and we'll get to this. Right, so M is the midpoint of DE. That's quite nice. So straight away from that, I can label these little half B's here, because the full length was B. So if it's the midpoint, they're both going to be half B. X is the point on FM, such that F to X, X to M is N to 1. So this is in a ratio. We've got N to 1. We don't know what N is though. CXE is a straight line. See if I can get a different colour for this. So C to X to E. There we go. Is a straight line. Okay, work out the value of N. Now we've got three different parts of this line that we could look at now. We've got the full length of that yellow line, C to E. Okay, so I could look at the vector C to E. We've got from C down to X, part of the line, C down to X. And we could also look at X to E. Okay, so there are three potential vectors that I could look at. Okay, right, so which one can we actually work out? Can we work out any of them as it stands? Now the one that stands out to me to start with is this C to E. Okay, because we can work that out actually without doing any extra maths there. So to get from C to E, I go along the A. So I'm going to write that down over here, C to E is A, and then I can go down these two half B's, which is just an extra B. So to get from C to E is A to B. Now, let's have a look at another part of this line. So what about F to M? Let's have a look at this actual line here that we're moving along. So to get from F to M, how do I actually do that? Okay, so F to M. To get from F to M, I can go up this A minus B, along that, what's that at the top? Along the A, so plus A, and then down this little half B, so I can add in a half B as well, so plus half B. And that will allow me to get from F to M, okay, just going up around the outside. So let's simplify this down. A add A is 2A, and then minus B add half B is minus a half B. Okay, we're getting part way there. Let's see where we can go from here. Okay, so because we've got this n part of this line, we can't actually figure out how to move part way up that line now, so we're going to have to start to use some algebra for this one. Now I could have a look at, let's say, let's go from C to X. How would I get there? So let's have a look. I could go back down. Okay, let's have a look. Right, I'm going to do this. There's lots of different ways of moving through this. So I'm going to move down here, and then I'm going to go up this line. So I'm going to go the reverse of A minus B. So that'd be minus A plus B. If we do the reverse of that, let's write that down over here, C to X. So I'm going to do minus A plus B. And then I'm going to move part way through this line F to M, and that is n lots. Okay, we don't know how far, so I'm going to write this using algebra. So n lots of that. Now we have got that vector written down over here, F to M, we've got it written just here. Okay, so I'm also going to do part of that as well. Right, let's just, that was not what I meant to do. Let's move that away. Obviously not done this bit before. There we go. Right, so let's add in n lots of this vector here that we've simplified down. So I'm going to add in n lots of 2a minus a half b. Okay, and that would get me from C to X. Right, so let's expand that out. We get minus a plus b plus 2an, times it by n, minus half b n. Okay. Now what I'm going to do is I'm going to put the a pieces next to each other here, so we can start to have a look at this separately. So if I move the a pieces next to each other, we've got minus a plus 2an and plus b minus half bn. Okay. Right, so I could actually have a look at these two parts separately. So with these a's, I can factorise this, take a out. So I can have a brackets minus 1 plus 2n, and factorise b out of this one. We get 1 minus half n. Okay, so we're starting to get this little link between that a plus b that we had over here with that one vector that we were looking at. So we've got this a plus b, but we've got these pieces with it, these brackets that are still including this letter n, so we're going to have a look at what we can do here. But we know that as it is a multiple of a plus b, that these two parts of the bracket here, this minus 1 plus 2n and this 1 minus a half n, have to be equal to each other. Okay, so what we can do is just set those equal to each other as an equation and see if we can actually solve that and see what we get. So if we do this to the side as an equation, we get minus 1 plus 2n equals 1 minus a half n. Okay, let's try and solve this. So add 1 to both sides to get rid of this minus 1 here. We get 2n equals 2 minus a half n. Add half n to both sides. We get 2.5n equals 2. And divide both sides by 2.5 or 2.5. You can do this on your calculator. You get n equals 0.8 or 4/5. There you go, n equals 4/5. Right, so let's have a look here. How far have we got with this question? It says work out the value of n. Is that all it wants me to do? 4/5. Oh, okay, there we go. We've got our answer then. 4/5. I sometimes get a bit carried away with vectors as to what I'm actually working out. I just like to work out everything. Okay, so I mean that's probably definitely the most complicated one on there, this vector question. This is the thing to be looking at, those three parts of that line. Okay, and which ones can we work out? The first part, C to E, we could work out quite easily, and then we could have either looked at C to X or X to E, one of these. Now I chose to look at C to X on this one. I'm sure it could probably be done looking at X to E as well. But that's just the way that I chose to look at that. So C to X, we got the minus a plus b, C to X, and then we also did our n lots of that line and figured it out using algebra there. So you're looking for that link, that common multiple between the two brackets, or that was just a plus b in that c to e. Okay, so that's that final question there. Again, I've going to make some videos on these vector questions, these more complicated ones, but that's the end of the paper. If you found that useful, again, please like, please comment, please subscribe, and I'll see you on the next one.